Dean Zaris, founder and CEO of ClearFactr. Today we're going to take a look at a number of features that we've covered in previous videos, but we're going to kind of integrate them all into one shorter but very compelling example, combining a whole number of capabilities as a demonstration of something that you could build very easily with ClearFactr that would be extremely difficult, if not impossible, without it. So what you're looking at here is a model that has actually there are two external data sources, Databricks in this case, and these cells, as we'll look now, control a bunch of other cells, and they're controlled in turn by two states, a so-called buy-side state and a sell-side state. And as you see here, we've got all our 50 states. And when I pick another state like this, a query executes, actually two queries in this case, and we get new statistics over here and 5 rows over here corresponding to that chosen state. So down below at the bottom, we've got a bunch of sort of arbitrary calculations, hence the name, an arbitrary compute model. And that's kind of the point, demonstrating how we've got 4 queried sections of data being placed anywhere we want in this grid, actually being backed up by 3 million rows of mortgage data. Down at the bottom, we've got differences between the buy-side state and the sell-side state. So we've got the differences in the number of mortgages in each of those states, the difference in the max assessment, the difference in the max mortgage, the difference in the average equity. And then down here, we see an NPV, and the NPV uses a discount factor over here, 3.5%, and a bunch of cash flows that's come ultimately from these equity values up here. And as we crank up the number of past generations, we'll see at 4 levels, 5 levels, 6 levels, we'll get to here, and also the 2 states. So there's Delaware, there's Colorado. Doing that one more time, if I just pick another state, let's say Hawaii. And now, there we go. So now we've got data for Hawaii in here, and the NPV changed. All right, so behind the model, I've got my development environment. And this is actually a real world unit tester for some of the code involved. And I've got some output over here created by this unit tester. I'm going to run it again. And this is just a bunch of logback config stuff, but we're now reading the latest values out of the model, and then we're doing something else. And I'm going to explain that a little further in a second. Now, latest values happen to be Arkansas and Colorado because I haven't hit the save button. So let's hit the save button and we'll change that. And we'll rerun this again. And here we go. So again, getting the latest values. There's Delaware and Hawaii. And let's explain what this output is. So this is just, again, some demo code, but real code happens to be written in Java, using this model to do what it does. So we see the so-called factor A over here, the count, the max assessment, the max mortgage, average equity, and that NPV value. And there's the NPV value down here, again, 2,104.36. So that's that, and just spot checking some other stuff, the max assessment, negative 7.2 million, and so on. But let's dig into these things here, what I call the alternative trades. So we've got buying Florida and selling New York, buying North Dakota, selling South Dakota, and 2 different factors, 10 and 40%. And here are the results. So what's actually going on? We're in this code, we're making one endpoint call to the model through the API. And on the fly, we're generating these 2 scenarios, and the model is computing these things and sending us back the results. All of this happens at the server side, and it doesn't affect the model in any way. Any number of other people could be using the model simultaneously. They would never know that this is happening. Like some other past API demo, we actually did write some values to the model. But as you can see, if I sort of lift up the curtain a little bit here. If I were to put in North Dakota and South Dakota, we'll get a new NPV of 2531. And I didn't change the factor. That's better. 2372.94. There we go. 2372.94. And the count 13,410, and so on. So as you see, I've got the values over here being computed on the fly, the model being left alone over here. I haven't saved these things, although if I did now, we can wrap things up this way. If I run this one more time, getting the latest values, there we are. So there's North Dakota and South Dakota, and that NPV that we talked about before, 2372.94, also down there. Hope this you found this interesting. Please contact us to talk about how you can use any of these things in your own system from any type of code that's capable of making a REST API call and being able to expose calculations that might have been buried in source code out through a familiar spreadsheet interface, and leaving all of your data off in a cloud data warehouse where it can be leveraged by other things instead of being buried in your spreadsheets. Thanks so much. Look forward to the next videos.